Okay, so question 3. Express the voltage in figure 3 as a function of time. So what does this question mean? It just means find the equation that describes this line. Find the equation of this straight line. So this is pretty secondary school stuff already, right? So equation of a straight line is given by y equals to mx plus c. In this case, the y values is actually voltage. So instead of y, I'm going to say v. And the x values are actually t because it's time. Okay? Then I'm going to say that, okay, so m is the gradient, right? M is given by the gradient of the straight line. And c is the y-intercept. So let me just write this down. This is the gradient. This is the y-intercept. Okay, so gradient of a straight line, we need 2 points, right? So let's choose the 2 endpoints. So here is 0, 0. And here is this, like that, right? It's just the coordinates of the 2 endpoints. So what I'll do is just take, okay, so gradient is given by y2 minus y1 over x2 minus x1. So this is 100 minus 0 divided by minus 0. So this will give me 100,000. Okay, and what is my y-intercept? You see this straight line, it cuts through the y-axis at 0. So actually, c is just 0, so I don't need to write that. So I just plug in 100,000 here, 0 here. What do I get? V of t, v as a function of time will be 100,000 t. Okay, there's actually plus 0 here, but I don't need to write that. So this is my answer. Okay, and what did it say? Determine the frequency in hertz. So frequency is given by 1 over the period. How long is one period? It's just this. You see, it repeats every 0.01 seconds. 0.01, 0.01. So this is the period is just 1 over 0.01, which is equal to 100 hertz. Right? Okay. So draw on your answer book current versus time plot of the resistor and determine this. So let us draw this plot first. Because this is a resistor, right? It's a 20 ohm resistor. The relationship between current and resistor is just given. Resistance is current and voltage is given by this. So V is IR. So that means if I know the voltage, which I do, right? It's just given by this. If I know the voltage, to find the current, so to find current will be V divided by R. I just need to divide by the resistance. So let us look at the graph, right? Let us look at the graph and look at the special points. So what are the special points? It's just the endpoints. So here, when voltage is 0, that means the current is 0 because there's no voltage difference for current to move across. So 0 is just 0 current. And then here, when it is at 100 volts, okay, when V is 100 volts, that means I is equal to V over R, which means 100 volts divided by the resistance is 20. So this will be 5, right? This will be 5. Yeah, 5 amperes. So at time equals to 0.01, my current will be 5 amperes. So that means my plot will look like this, like this, like this. It will go up, it will land at 5 amperes, and then go back down. Okay, and then repeats like that. 0.01, 0.02, and it's the same thing. Okay, so just like that. That's your current plot. So I against T. This is your current plot. Okay, determine the frequency. Because the period is the same, the frequency will be the same. So just like in the first question, the F will be 100 hertz. Okay, 100 hertz like we got here. So what is the minimum and maximum current? So looking at the plot, right? Minimum means where is the current the smallest? The smallest current you can go is just 0. You see, I can make my current go all the way down to 0. So 0 is the minimum current. So I minimum will be just 0. And what's the highest current you can go? So let us check. Based on the graph, I can go up, go up, go up all the way to, see, 5 amperes. So my highest current is just 5 amperes. Done. Okay, so determine the maximum power dissipated by the resistor. So in this case, we can just use P equals to V squared over R. Why I use this? Because all the values are quite immediate. But if they want P max, then see this resistance, it cannot change. So R is just R, but the voltage will change over time. If I want the maximum power, then I just have to use the maximum voltage. So where is the maximum voltage? See, the maximum voltage occurs at, I can go up all the way until 100 volts. So 100 volts is my maximum voltage. So this is 100 square divided by my 20 ohm resistance. Let me check my answer. What is this? I forgot. Okay, so this will give me 500 watts. Okay, that's the answer. Determine the average power dissipated by the resistor. Okay, so for time varying sources, okay, let us go to the simple case. In the simple case, we can use V squared over R in DC settings, right? In DC, the current is constant, the voltage difference is constant, so I can use this. But the thing is, in this question, V changes with time, right? The V is not constant. Okay, like for example, let's go back to this graph. See, at maybe this time it will be 50 volts, but then later at this time it will be 100 volts. So the voltage keeps changing. So the power keeps changing. So how do we deal with this kind of situation where the voltage or the current changes with time? In this case, we need to use RMS. Now let me explain what is RMS. Actually, right, the RMS power is the equivalent average power dissipated when you use a DC equivalent. Okay, let me explain what that means. So let us suppose you have a AC source, right? The RMS power means that if I change this source into a DC voltage, source, then the power dissipated by this, let's say this is 100 watts. If I can change this into an equivalent DC voltage source, see this is DC, this is AC. If I can change this to an equivalent DC power source, then this 100 watts that it dissipates here will be the RMS of the AC. Okay, it's just the DC equivalent of the AC, because the power here, it will fluctuate. But then the power here is just constant. So if I can find this power value, and then I model it as an AC, then this will be my RMS value. Okay, it is my RMS value in the AC world. So the power, the RMS power is the DC equivalent power. Okay, if I pretend that my AC source is a DC source. Okay, I hope you all can understand that. So anyway, that means I had to take this. Yeah. So if I use PRMS, sorry, not PRMS, P average. Okay, the P average is given by V RMS squared divided by R. Okay, so the question is how to find this, right? So we have to use back the formula from the tutorial. So V RMS is given by, remember, root mean squared. So first root, then mean. Okay, sum of it over a period divided by period. Then the square, you square the voltage source. Okay, so what is this V of t? Remember from the first question, we got V of t is equal to 100,000 t. Okay, and then what is the period? The period is 0.01. So let us just sub in all the values. Sub in all the values, you get 0 to 0.01. 100,000 t, but don't forget to square it because its root means square dt divided by t. Okay. You can perform the integral manually, but I suggest you can use calculator. In fact, it's actually quite simple enough to do it manually. But I will use my calculator. I'll solve this. Oh wait, sorry. This should be 0.01 also. Okay. You can find this value using your calculator. Then after that, you take this whole square root divided by 0.01 thing. Then you should finally get 577.35. So this is VRMS. Okay, so we're not done yet. So to find the average power, you take VRMS squared divided by R, this squared divided by 20. You should get about 16666 watts. Okay. Okay, next. Find the electrical energy cost. Okay, if the electrical energy cost this, what is the cost for turning it on the entire day? So they tell us that energy is equal to power times time. Okay, so let's find the amount of energy we use first. Now, you see the cost they give me is in kilowatt hour. So I had to make my units in kilowatt hour, right? So the power is this, but this is in watts, right? What did they say? In kilowatts. So this, we had to change it to kilowatts, which is just divided by 1,000. So this kilowatts, right? And then the time, because it's an entire day, so it's 24 hours, right? Kilowatt hours. So we have to use 24 hours. So see, kilowatt times hour. Okay. So 16.666 times 24 is 400. And then kilowatt times hour just gives me kilowatt hour. Okay, so this is my energy. Now let's find the cost. So for every kilowatt hour, you need to pay 6 cents. So the cost is 6 times 400. You should get $24. So this is your cost. Okay. So yeah, that's the answer. Is that all the questions? Yeah.